First type of reaction is called synthesis. Now this AB, we call it a generic equation. So this is like element A plus element B is coming together to make compound AB. Okay, and just to refresh your memory, on the left side of the arrow are always the reactants. So A and B, elements A, elements B would be reacting to form a product over here on the right side of the arrow. Okay? So this goes in that first blank. Okay? Two or more reactants make one product. Come together, we also can call this combination, where you're bringing two things together, sometimes three things together to make one compound. Okay? So we call this the generic equation. Now we're going to look at a particular example. So this will go in the next blank where that says example with the arrow. Okay, so that was where you'll be filling it in. So if we have sodium metal and chlorine gas, because these are the elemental forms, sodium metal. So this is solid, this is chlorine gas, because that's how it exists at room temperature. Those two elements come together, they form sodium fluoride, which is our compound over here. Doesn't always have to be a metal and a gas. It could be two solids, could be a solid and a liquid, could be two gases, okay? So could be any of those things coming together. In this particular case, sodium would be a solid metal. Chlorine is a gas in its elemental phase. Don't forget that chlorine is one of those diatomics. There's 7 of those diatomics. Your Dr. Brinkelhoff, your 7 rule, starts with 7, makes a 7. Don't forget hydrogen's the 7th. So that would be starting at nitrogen on your periodic table is number 7. Dr. Brinkelhoff also gives you the 7 in the Brinkelhoff part as to who's diatomic, because you got to remember those here. Whenever they're by themselves, you got to give them the little 2, the twin. Okay? So that's an example. Now we're going to look at some examples here to practice after we see our dancers. So we have our 2 by themselves, just having a good old time, and then they decide to dance together. So linking of the arms would be like forming a chemical bond here, and that formation of a chemical bond is what holds the compound together. Now remember, it could be an ionic bond, could be a covalent bond, some kind of chemical bond holding it together. Okay? Now let's look at some examples and see if we can follow the rule here. We need to see 2 or 3 things coming together to make one thing. So in number 1, is that considered synthesis? So would number 1 be synthesis? No, it would not, because you have one thing breaking apart into 2 separate things, right? How about number 2?
Yes.
Yes, we have 2 separate things coming together to make one thing. So that would be good. How about number 3? No, it's correct. Look, we have 2 things over here, but we also have 2 things over here. So that doesn't fit our rule of 2 or more things coming together to make one compound. How about number 4? No, that one also looks like number 1, where you have one thing breaking down into 2 things. How about number 5? No, same as kind of number 4, breaking down. How about 6? Yes, we have 2 coming together to make 1. And last but not least, number 7. No, good, because that's breaking down there as well. So speaking of breaking down, this would be what we would consider the opposite of synthesis. Synthesis is also known as combination, right? Combining. Okay? It's called decomposition. And you know it from biology where bacteria do it and they break things down for us. But in chemicals and in chemistry, we also have chemicals that break down from compounds into their elements or to smaller compounds. So in this case, we would say compound AB, this is now compound, is breaking down into its separate components. And sometimes they're going to be the elemental components, most of the time actually. Occasionally it would be into a smaller compound. But a lot of times you'll see it just break down into its elements. So we have, once again, one reactant breaking down into multiple products. Okay, more than one product. Okay, so far now you should have down to line 3. So let's look at an example. The reverse, if you took sodium chloride and broke it down into its elements, it would look the opposite of the synthesis, breaking down, splitting apart. Now, yes, that's not balanced. I understand that. We'll get to balancing later. Balancing, we have to follow the conservation of mass rule in order to do that. We're going to get to that in a minute. But yes, technically everything should be balanced if we want to follow how nature works. Okay. Now let's look at a more, let's look at some examples and see if we can pick them out. Oh, the dancers again, I forgot about them. They're dancing happily together, but they unlink from each other, their arms disconnect, and now we have two separate people jamming out by themselves. Okay? Now let's look at some examples. So, number 1, would that be considered decomp? Yes, one thing breaking down into two things. How about number 2? No, but what kind of reaction is number 2? Should be synthesis. Very good. Two things coming together to make one thing. How about number 3? No, it's also synthesis. Very good. How about number 4? Yes, we have carbonic acid is breaking down into water and carbon dioxide. How about 5? Yes, we have magnesium hydroxide. Remember, hydroxide's here. Breaking down into magnesium, oxygen, and hydrogen, 3 different separate elements. How about number 6? No, because that's a synthesis. Copper is being added to oxygen to give you copper 1 oxide. And last but not least here we have calcium hydroxide turning into calcium oxide in water. So that's a yes, good. Single replacement. Now there's 2 types. So what you're going to do in your first row, you're going to write this one. This one goes in the first row. This one's going to go in the third row. We're going to skip the second one for the examples. Okay? So the first row is showing you that you have a compound and it's being added to an element. So it's always going to be a compound plus an element that gives you a new compound and a new element. Now the top one you see, the one that's switching places, we call it single replacement. Sometimes you'll also see it noted as displacement. It can be single displacement. Means the same thing. But the ones that are exchanging places are the B and the C. Now the B is in the anion position. So this one we call an anion switch. So you're switching the anions out. So you're switching out basically the nonmetals too. These are always going to be nonmetals. That switch here, nonmetals. The second generic here, which goes in the third row of your notes, we see the C is replacing the A. And the A is in the cation position. So that's usually going to be a metal, or it can be hydrogen. Because remember, hydrogen can go to H+. It could be an acid. So in that particular case, you would have the cation switch, where it is a metal or hydrogen switching places. Okay? So that's for the first and the third row of your notes. Now looking at the examples, which are going to go in the second and the fourth row of your notes, by the way. First example up here goes in the second row. Now, as you can see, the Br is switching places with the chlorine. So that is a nonmetal switching with a nonmetal. And as you see, we get our new compound sodium chloride. But we get our new element too, which is bromine, which is a liquid at room temperature, if you remember. It's also one of the diatomics. Okay? Now, looking down here, this is one where we're working with hydrochloric acid. This one goes in the fourth row, by the way. It's going to switch with magnesium. So we get magnesium chloride, our new compound, and hydrogen gas will bubble off. Now we're going to see this one in the reactions lab as well, where we're going to see the gas bubbling off. Okay? So those are some examples of single replacement, also known as single displacement, either or. Okay? So keep that in mind. You'll be able to see that. Good? All right, so let's look at some examples here. Would number 1 be a single replacement? It is not. Why is it not? It is a synthesis, two things coming together to make one thing. How about number 2? That's a no too, because what is it? This one is decomp. Very good. One thing breaking apart. How about number 3? Yes is correct. Let's look. Is it a cation or an anion switch? Who's switching with who here? Aluminum switches with hydrogen, right? Because aluminum is now in the compound. Hydrogen is now by itself in the element. So this one would be single replacement. It would be a cation switch. Everybody see that? How about number 4? No, that's synthesis. Good. Okay. How about number 5? Yes. Who's switching with who in that one? Yes, the zinc is switching with the Pb because now you get zinc oxide and lead as its elemental form. So the zinc and the zinc basically, because zinc is a little bit more reactive than lead, it comes in, it like kicks it out. Says, see you later, I'm taking this spot. So the more reactive metal kicks out the least reactive, or the less reactive metal. In this case, lead is less reactive, so it kicks it out of the compound and takes its place. Okay? How about down below for number 6? And who replaces who? Copper is replaced by the iron, good, so you get iron 2-sulfate and copper element by itself. Once again, in that particular case, the iron would be more reactive to kick the copper out of its spot that's attached to the sulfate. Okay? Double replacement. And this is probably the easiest to spot because guess what? It is always compound plus a compound gives you a new compound and a new compound. So everything in it is a compound. There's no elements involved. It's all compounds. And you have a double switcheroony going on. You have the A recombining with the D, and you have the C combining with the B. So both of them switch places. Double replacement, double displacement mean the same thing, just so you know. Keep that in mind. Okay? So let's go ahead and see an example here. This example, we have sodium nitrate plus potassium chloride. Now, if we think in our mind carefully, the sodium is the cation over here. It has to combine with the anion of the other one, so it's going to combine with the chloride. And the nitrate's the anion of the first one, so it's going to combine with the cation of the second to form the potassium nitrate. So that's double switcheroony here going on. And remember when you're writing chemical formulas that you always write the cations first. They are the first in the formula. The anions are always written second. Okay? So some of that formula writing and naming stuff is now coming back into play here. And so you might need to kind of get some help with that if you don't remember it from Unit 4. Okay? So, Let's look at some examples here. Looking at number 1, is that a double replacement? Yes. If you look here, we have a compound, which is magnesium hydroxide, with another compound, hydrochloric acid, giving you magnesium chloride and water. So yes, we have all compounds up there. We have the 2 switching places. The H on the acid goes with the OH on the base here, so we end up with water as one of our products. How about number 2? No, number 2 is a type of synthesis. Good. How about number 3? Yes, compound, 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 compound. Sulfate's now going with barium, and sodium's now going with chlorine, so it is definitely a yes. How about number 4? No, because number 4 is synthesis. Good. How about number 5? Yes, we have compound, 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 compound. Do they switch places? Yes, you see that. How about number 6? No, number 6 is a type of decomposition. Very good. Now for neutralization. Neutralization is a specialized type of double replacement because you do have all compounds there. But it is always the acid, which we represent by HA, because remember, acids always have that H in the front, plus a base, because we always have the hydroxide component there for the base, giving you water as one of the products. And the BA combines to form a salt. Remember, any ionic compound is considered a salt, not just the NaCl we put on our food. So any ionic compound is in the class of salts.
Why do you particularly call salts?
Because that's what they were named, salts.
You don't look like salt.
Well, I don't know. What would you tell me a salt looks like? Little crystalline structures is what I think of when I think of the word salt. So, double replacement reaction, but it always has an acid base that forms water and a salt. Okay? So let's look at one of those. We have hydrochloric acid over here as the acid, HCl, plus potassium hydroxide, which is the base. So we're going to get water. The water always comes from the OH combining with the H, because HOH is 2 H's and an O, which happens to be water. Okay? And therefore, the K and the Cl will come together to form the salt. Okay? Everybody see that? So H from the acid combines with the OH from the base, and that's always going to give you water as one of your products. Now we only have a couple more left, so let's go through them. Combustion. Always a good time, because combustion means what? Explosive, or fire, or burning. Yay, right? Not always like burning like flame burning, but it means it's actually going to... Oh, forgot our neutralization examples. Let's go through them real quick. Number 1, is that neutralization? Yes, because we see acid, base, water, and salt. How about number 2? No, good. You see the acid here, but do you see the base or the water? No, so that was just a regular double replacement. How about number 3? You see the base, but no water, okay, no acid. How about number 4? Yes, this is acetic acid plus lithium hydroxide base, water, HOH is still water, and our salt is lithium acetate this time. What about 5? Base, acid, salt, water, yes, check, good. And the last one. Acid, base, salt, water. Good. Check. So we need to look for those components. Now for fun combustion. Let's look at that. There are two types of combustion, so once again, you're going to have to skip rows here. This one will go in the first, and this one will go in the third. And what I mean by organic is I'm talking about a hydrocarbon. Something with C's and H's in it. When we say organic compound, we're talking about something with C's and H's in it. Hydrocarbons. Okay? But, as you'll notice, both of their other reactant is what? What do you need to burn stuff? Oxygen. So oxygen's always the other reactant. Okay? Now for organic combustion, you get identical products each time. The products of organic combustion are always going to be carbon dioxide and water. Those do not change. Organic combustion is a carbon compound, hydrocarbon plus oxygen gives you carbon dioxide and water. But the metallic combustion, you always get a metal oxide as your product. And what else can metallic combustion kind of resemble here? What other reaction type do we see happening here? Synthesis. This one, it can also be called synthesis because you're taking two things and combining them together. But when you see a metal with oxygen, you know it's metallic combustion here. We did this at the beginning of the year. Remember, we took that magnesium strip and burned it. What did it make? That made everybody freak out? The big, bright white light, right? That would, whoo! But when you had the leftovers, you had an ashy white substance, and that would have been your magnesium oxide left over. Okay? So let's look at some examples. So this one, the examples are going to go in the second and the fourth row. First one is methane and oxygen. Methane. That's what we have coming out of our gas outlets. And we burn stuff with at our homes because methane's an easiest natural gas source of energy. So methane plus oxygen gives us carbon dioxide and water. And I used the example we did at the beginning here with the magnesium strip. Burning the magnesium gave you the bright white light, and we got magnesium oxide out of it. Okay? So the only thing I do want you to do for homework on the rest of your packet is to complete the identifying the types of all the reactions. Now, some of the lines are not in the right place, so just make a line if you're missing a line. But just identify what type it is. You do not have to balance anything yet. So only identify the types for homework. 1 through 26, identify the type. Okay?